Many people, unfortunately, who think, well, if I can do BIM, I can do everything. Tomorrow afternoon I can walk on water. That's not the case. It is part of a process. And hopefully in 15 minutes I'll be able to pull those threads together so you can see our view and hopefully your view of how the things come together. So to start off with, what are we looking for? What are we trying to do? We're in the 21st century. We want low carbon construction and we'd like intelligent construction. Everybody wants to be perceived as intelligent. So that's what we're calling it. 21st century low carbon intelligent construction, or smart if you want a shorter word. And remember, all the things that we do today and in the future, we've got this awful target that we've got to try and get to. 80% reduction in carbon by 2050. I have no clue how you are going to do that. I have no clue. I won't be here, so it's your problem. So over to you. You can sort it out. I tried for a year with a group of august people. I've still no answer to that question. So welcome to 2050. Let me know. So why change? Everything's fine. The construction industry is great, best industry in the world. Not. It's a fantastic place to work, but it needs so much doing to make it effective. I can't go through all the pieces, but just concentrate on that. These aren't my figures, and we can argue about them. Is it 89%? Is it 87%? Is it 90%? It doesn't matter. If it's 89% on cost, between 97 and 2006, it's too damn much. Clients can't afford it. We need to bring costs down. And part of an effective process, a lean process, is to bring costs down. So the reason we're doing all this stuff, if you want to call it stuff, is because that's not right. Now that was pre the recession that hit us in 2007. So that's the past, and the future is very, very different. And here is the future. This is Peter Hansford's 2025 construction strategy. I'm sure you've all read it. Most people read it? Most people seen it? Good. A stonking good document, if I were to say so. Lots of things that come out of government are perceived as no good, don't bother, throw it in the bin. I think this is particularly good because this is what clients want, and this is what we should be delivering as a collective. I don't know whether you agree or disagree. Why would any client not want 33% reduction in costs? Good idea? Bad idea? 50% faster delivery. Good idea? Bad idea? Good idea. Lower emissions, back to the carbon again. And also this one, not necessarily in everybody's book or in everybody's mind, but I think it will be in the future as we sink as an economy down the world order. The UK order will sink because, I'll come to that in a minute. So trying to get 50% more exports for the good things that we are very capable of doing in construction work. We're perceived as being very good in construction. Here's the world. We've all seen it before. It's a very changing world. The pendulum is moving to the east and to the south. Now that means in 12 years' time, the predictions are that it won't be 8% of GDP in construction, about 100 billion, 120 billion, whatever it is at the moment within the UK economy. It'll be a fraction of that. So we need to get smarter. The 66 million people in this country will have to get smarter about taking more work from Europe and taking more work globally. And I think part of what we are doing collectively, and BIM is a part, is making ourselves more effective. Now it's slightly comical, we can have a little laugh at it if we wish, but unfortunately in a lot of places in the construction industry, if you say construction, immediately people think wheelbarrow. And quite often it's a broken wheelbarrow. You'll notice the wheel is not connected to the wheelbarrow. And when people talk about innovation, they think, oh, we'll have a shiny wheelbarrow. Well, frankly, in the world that I think we want to work in, we don't want any wheelbarrows or wheelbarrow mentality, if we use that as a backdrop. And this was the front page of the building magazine back in the last century in 1996. That's what everybody thought a builder was. If you didn't have your bum hanging out, And no PPE. The only difference today is they've got PPE. Now we could argue this is going to go on forever, and it will do. I'm not naive enough to think this is going to stop tomorrow, nor is this going to stop. It's very prevalent in places, third world countries like Lagos, Nigeria, even the Indian subcontinent. But we've effectively produced a digger, JCB produced a digger, which makes this semi-obsolete. But here is what I think is the future. A very, very big factory at Lang O'Rourke, and if you look carefully, you can see a little person. That person is working undercover, making manufactured goods that fit together like that. Not like that. That's the difference between off-site manufactured componentry and crafted construction. Very simple with your finger. And then we spend millions and millions of pounds with the Dow chemical industry to fill it all in, to make sure it's all watertight and weathertight and airtight. So here's where I consider to be the future. This is where I think we are still substantially. Car manufacturers, I don't know whether you're a car freak or not, but it's not important whether you are or not. The VAG group or the VW group, all these cars are manufactured by the same owner. They're all different, but they're all the same. And I think this is what our vision is of looking forward. Can we have 80% common platforms and then 20% choice rather than 100% of choice? And I'm not talking about 100% in totality. I'm talking about, because some people will be able to afford the ultimate choice of saying whatever you want, blank piece of paper. But not everybody can afford that. And we've seen the horrendous costs that delivers, 89% unaffordable in anybody's book. So even at the high level of automotive, with the Rolls-Royce Ghost and the BMW 7 Series, to name but two, they are owned by the same person, by the same manufacturer. This is the same as that. And if you go to the Rolls-Royce factory and say to the guys that are showing you around, what does it say on that box? And it says BMW. Or we're in a Rolls-Royce factory. And they would wish that we didn't know that, because they're selling a superb brand called Rolls-Royce. It's all about brands. And we're very agnostic towards brands in the construction industry. I'm sure you'd agree with that. So this is a brief bit about us. Founded in 2004, not-for-profit, member-based, 100 companies, business to business, and it is everybody. Clients being the key part of what we do. Everybody else works for a client. No clients, there is no construction industry. No clients, no construction industry. And we are unique. And we exploit off-site. That's not a surprise to you. This is the group that I have the pleasure of working with on a regular basis. And you'll notice they're not all architects. They're not all QSs. They're not all clients. It is a collective. That's where you get, that's where I think you get the future thinking from, because it is a collective. It isn't about one group. Here are some of the names that we work regularly with. And here are client imperatives. I wanted to touch on client imperatives just in case we don't talk today about the client. Here's what every client wants. Ask them. Cost, time, quality, safety and sustainability. That's all they want. They're very, very simple people. They want 0 defects when it's finished, and occasionally they'll give you a design freeze if you push them. Now, build off-site in practice, I call this a Trojan horse, and it's a collective of all these things. It's not off-site's not the silver bullet, BIM's not the silver bullet, DFMA. Everybody know what DFMA is? No? Design for manufacture and assembly. All those cars you saw, all the aeroplanes that are built, are designed for manufacture and assembly, not by architects. Architects, for the most part, do not understand the terminology DFMA. Rob does, because he works in the car industry. That's what they do. We want low carbon. We need to change still our culture and behaviour. It's not good enough. And logistics and supply chain takes on a whole new part when you're talking about off-site construction and the things that we all believe in. So I call it 2D for simplicity, and BIM takes us one step closer to off-site automatically. You didn't have to do anything. You'll talk to Jamie later. They've exploited this and got many, many stages on by exploiting the use of BIM and all the tools I talked about earlier on. So it could be a school. This is a Bryden Wood school. It's put together like Lego. It's very simple. Lego fits right first time, every time. 3D, the ultimate, fully volumetric, you want to call it volumetric, fully manufactured, but it's in a factory. And this is a second-hand factory. Most people think you need a new factory. You don't. You can use an existing factory. There are many factories that are sitting around redundant. You can use them. Put a crane in them. This is a BAA example. And here's the beauty of what happens on site. A wet, horrible evening at Heathrow, 1.6 kilometres of fully finished unit. And when I say fully finished, I mean electrics, finishes, glass, everything. That's perfection. So who are the leaders? All these groups around the outside, they are using or utilising Offsite. Custodial, MOJ, as most of you will know, I'm sure, Cook and Wood was a lead example in terms of what you could do by building a prison. Building off-site, assembling on-site, component pieces, fully completed. The BIM library. How important is the BIM library going to be in the future? I think this is a major, major part of what BIM will lead us to, because it will be a library of components and sub-assemblies that we can start putting our 80% sub-assemblies together. I think that will be a key part. So I've left Jamie's great work out in St. Petersburg off here, and I'm just capturing a couple of examples of the things that I think had leadership. Here is an example in Wolverhampton of doing things across many shores. They were built in Cork and delivered, 25 stories, still standing, contrary to popular belief. You know, these things fall down because they're built off-site. Not true. 805 modules, 24 million quid's worth. And the latest one, which I won't go into because we have the expert sitting here, he'll talk more about this. This is breaking news. This is the art of the possible, not the impossible, and Rob will refer to that later. A few examples, we're still okay for time, I think. Two typical examples I got from Langeroog. Remember, this is what we're up against every year. You go to work and not everybody comes back. It's the lowest in history, so that's on a scale of 1 to 10, that's fantastic, but people in the construction industry can lose their lives. We heard about an example at Crossrail. You don't necessarily have that when you're working in a factory. It's much harder, much more onerous to work in a factory, much easier for the people. So imagine a Loughborough University built traditionally, 100 people on site, including 50 bricklayers, 30 scaffolders, and 30 miles of scaffold tube. And remember, scaffolding adds 1 to 2% to the cost of a job. Do we need it? I'd suggest we don't. So here's an alternative done in a similar way. 50 people on site, no scaffolders and no scaffolding, because it was done off-site, using BIM-enabled technology, using DFMA, using all the tools that we talked about, doing it in a smart way. Probably the most recognised example, with no less a person than Lord Rogers, the beautifully shaped triangular cheese grater, as is known, much to the disgust of the owners. And the guy that built it, Andy Dixon, the project director, he built it mentally 37 times before he went anywhere near the site. So he's got a very good understanding using BIM-enabled technology to work out how it all goes together, how the pieces fit together. So it's manufactured in Steepley, off the M1, junction 31 or 32, and delivered in component pieces on an evening by evening basis into deepest London. That's the way we think construction will be produced in the future. So some conclusions. Model T Ford, people who build BMWs are not mechanics. Think about that. Somebody somewhere is designing another set of toilets. The question is, why? How many more bloody toilets do we need? Surely we could have a book of toilets. Does this not make sense? And then would that not impact on those 89% uplifting cost? I'm sure it would help. Where is the Henry Ford of construction? Friend Einstein, insanity. You always do what you've always done, you'll get what you've always got. And then a few thought provokers before I turn it over to the mastermind, Jamie. The sandwich. If construction were putting a sandwich together, we'd go down the road and we'd buy a wooden cutting block, we'd go and buy some knives, a sharpener, some carrots, some lettuce, some butter, some bread, some ham, whatever we want to put in the sandwiches, and we would make a sandwich. And then we would find a skip and we put everything in that we didn't use in that skip. Okay? Now what do we do today? We buy a pre-made sandwich. It was made in a factory. Why? Because it makes sense. Number two, if we were building this little Volkswagen, we'd take all those parts to site, make sure we lost half of them in the process. Most would be invisible because they were covered in mud or cement or something else. And then we try and put it together, and then the client would complain that he didn't get a particularly good job. And then we try and fix it for him. Surely those days are over. I'd like you to read that and reflect on it. That's what we do every day. There has to be a better way. I'll pass over to the genius, the man, wherever he is, Jamie, and leave you with those thoughts.
Thank you very much, Richard. Just while Paul's connecting us up through to St. Petersburg on Skype, I'll just say a few words introducing Jamie Johnson. Jamie Johnson's director, Bryden Wood. He joined Bryden Wood in 1995 and has been one of those at Bryden Wood that's been key in terms of developing their building information modelling capabilities for seamless coordination of production information. The techniques that Jamie's been involved with have been on some very large scale, being used on some very large scale projects. Heathrow Terminal 5, the new Heathrow Terminal 2, big clients such as GlaxoSmithKline, Metropolitan Police Authority, and also the Circle rollout of 25 private hospitals. Jamie's also a member of the Cabinet Office BIM core team. We've had speakers such as Dave Phil, Mark Bew from the Cabinet Office BIM core team over the last couple of years here, and he's currently involved in the implementation of BIM across all the UK government departments. He's currently overseas working in St. Petersburg on a major project comprising the creation of a new district for the city. I think I heard it's increasing capacity of St. Petersburg by 10%. An enormous project, 15,600 apartments, schools, shops, transport, utilities, infrastructure, and health facilities. Looking for the nod off Paul.
Jamie, can you hear us?
I can hear you very well. Can you hear me?
Yeah, we can hear you loud and clear. Please present your presentation for us. Thank you very much.
And here are the scores of the Russian judges. This is very, very disconcerting for me and for everyone around me because I'm just looking at the screen in a room talking away. So yeah, this feels a bit weird, but here we go. Yeah, hopefully most people have come across Bryden Wood by now. We started out in 1995 as traditional architects, and over the last 20 years we've taken on our own structural MEP engineers, opened up our own factory, and we think we've been at the forefront of a lot of these initiatives that Rich and others have talked about. So design for manufacture, BIM. You can see on the screen we kind of take design for manufacture and BIM as a given now on projects because it's the way we work. We're exploring what we call design for efficiency and design for benefit. So assuming that you're going to use BIM and design for manufacture, what does that look like on projects? So a couple of quick examples of things we have done. Richard might have shown this earlier actually. This was something we did back in 2004 where we were using very large modules to limit the number of people on site. So this is an airport, it's a very high security environment, health and safety is paramount, security is paramount. So we've got to use big boxes with as much kit packed in as possible to limit the number of people on site while we had into working hours overnight. This is similar principle. It was for turning big empty buildings into data centres virtually overnight. So this one is in Madrid. These things were the biggest thing we could ship across the sea from Hull. And it was all the expensive kit, all the power and air handling things that you needed to turn an empty building into a data centre. So again, big volumetric things. We don't always use volumetric, and that's one thing that I think is slightly interesting about us, that we don't have a particular way of working. We have a palette of ways of working. So sometimes we use big volumes. This was a sort of flat pack kit of parts for building schools. So this is in our factory and this is a prototype. So sometimes we build our own buildings, like I think Richard showed one of our schools earlier. Quite often we develop elements, prototype them in our factory, and then we send them out to the supply chain to say, do that 100,000 times, but do it perfectly and make the bits, as Richard talked about, like Lego components where they're all identical. So that was in concrete. This is a similar principle but using timber. So again, I think we're a bit unusual that we use a mix of materials. So sometimes we use steel, sometimes we use concrete, sometimes we use timber. We tend to use a mix of these things. I'm sort of giving you some of the background so you can see how we end up doing what we're doing in St. Petersburg. In terms of BIM, we are similarly agnostic. Hopefully everyone in that room knows that BIM is not a software solution, it's a mindset solution. So this is something we did for Anglian Water Utilities, and it's done in SketchUp because it's a very intuitive, free and easy to use tool, and we do quite sophisticated projects in very, very simple tools. This is something we did for Met Police. That's that project using timber panels. And again, this is a fully coordinated fabrication model. So, as Richard talked about earlier, we built the whole building in the model before it ever got to site. There was virtually no waste from this site because all of the coordination was done through the model, all the pieces fitted together, and we had no trade contractor drawings for the superstructure and all the MEP and the timber panels on this, because again, all we did was use the models. We didn't need to produce drawings. So the efficiency, both in the production of information and the coordination and on site, was phenomenal in this, and it was a completely new way of working. It was driven by some unrealistic timelines set by the client, but actually forced us to find some very innovative and sensible ways of working, which we now roll out on projects. This is a different type of model where we've used the same software the car industry uses, and we've developed things down to the level where each of these components knows what it's made of and how much it weighs. So this is a virtual craneage study, so we can work out what's the biggest thing you can lift by crane, how can you safely move things around, how you can construct the building. This was actually, it never got used in the end, but this was the cheese grater, and that principle that Richard talked about, that building 47 times before we hit site, that's exactly the sort of thing that we're trying to use these models for. So this is something we did for Anglian Water. Again, it's the kind of showing the background to how we approach Gutenberg. This is similar to the project I showed before. This happens to be a stormwater tank, so we do a mix of all sorts of sectors, but one thing we're getting into now is utilities. So this was the SketchUp model that we initially did to design. This was then the finite element analysis model. So this was our virtual prototyping to test how the building worked. This was then the fabrication model done in Revit with Navisworks for coordination. This was the prototype that was in our factory. And in case you can't see the scale of that, this is some people standing next to it. It was an enormous bit of kit, this. And it was turning what would normally be a big civils job, so blokes with spades digging in the ground. We took it out of the ground and turned it into something much more like the oil and gas industry would do. And it was completely mind-bending for angling water, but now we've done it, it seems like a completely sensible approach. And this is the same thing on site. And Richard made the point about people redesigning things endlessly. Anglia Water would have designed every single stormwater tank and water treatment plant from scratch. And now they have a library of parts, a kit of parts that they can use for all sorts of different purposes. Probably that's what I'm going to get in touch with my phone. So this is Gutenberg, St. Petersburg. That gives you an idea of the scale of it. It sits on the River Neva, which is a massive, beautiful river just out that comes out of St. Petersburg. As Stephen said, about 50,500 apartments. This is only phase 1, by the way. So this is only the pilot project, really, for a lot more work they plan to do. So the first phase is 50,500 apartments, 25,000 inhabitants. Massive site. My good friend Professor David Hill tells me it's the largest level 2 compliant project in the world. I'm not sure that's true actually. Someone said that some of the World Cup stuff might be, so I don't know, but it's certainly very big, and we are using all of the same principles we've learnt from the government's early adopters, and we're applying it on a massive scale. And we don't know that that's been done anywhere else, but it's certainly driving a lot of our thinking. So again, picking up on some of the points Richard made, the strategy we said was to absolutely minimise the quantity of material. So that's in terms of drawn information, it's in terms of people on site, deliveries, craneage, physical components. Because it's a massive assembly project, we can spend an awful lot of time optimising every single nut and bolt of the connections, because once you've optimised it, you can roll it out a million times. We, again, picking up on Richard's point, very specifically said this is not a construction project. You have to think of it as a manufacturing assembly project. As soon as you get into construction thinking, you will fail. You've got to build 1 million square metres. You can't approach it in any of the ways that you normally approach a construction project. And that's been, we find that difficult to get across in the UK. It's phenomenally hard to get the Russians to get their heads around quite what we're trying to do and how we're trying to work. And there's been some massive learning curve we're going up, but we are starting to make some inroads into that. And one of the other key principles was to create a very limited set of components, so like Lego, that allowed us to do every building to be plot specific and unique, but using, like the car principle, the same basic chassis every time. So we developed, this is the full suite of components. As Rich talked about, there is a library of these things now which the architects draw down to create their models. It's worth saying actually that our role on this job, we are always the structural engineers, mechanical, electrical engineers on all the plots. We're the architects on 8 of the 40 odd buildings. And we developed the chassis kit of components and the design guides and things before the architects were appointed, which was absolutely critical to bottom all of this stuff out and work out exactly how to build the buildings before we let the architects design the buildings. And it was a massive lesson learned from the Athletes Village. We had a similar role in that. By the time we got onto it, the architects were too well entrenched, it was impossible to control them. So the cleverest thing I think SPB, the client, did was to engage us and develop the system before they let anyone start designing buildings. So this was the basic components. This is our, we call it our control building, so it's not really one of the buildings on the site. But we use this to compare our construction technique with traditional techniques. So for instance, we can weigh our buildings, which is the old buckets full of thing of how much does your building weigh. We know exactly how much your buildings weigh, and that's very important to us for reasons I'll come on to. So we can do these sorts of studies where we can schedule out virtually everything that goes into a building before we really know what the building looks like. We've got lots of these studies. We use the kit to start to develop health and safety principles. So we started looking at how you would build these buildings, building in safety zones. You could be building the frame on the upper stories while you're fitting out on the lower stories, and what that looks like and how you can use those sorts of things to optimise your construction programs. Off the back of that, we were producing installation guides, logic diagrams, planning sheets and 4D models, again, so we could really test the building principles and optimise everything before we ever got close to designing the building and hitting site. We were working at this sort of level of detail where we were developing all the interfaces and connections for the key MEP parts, again before we did the build. When we did the final presentation to the clients of all of the elements in the library and how all these interfaces work, it took about 4.5 hours to go through them. So I haven't got time to explain all the clever thinking behind this, but you just have to take my word for it. It's quite clever, quite amazing. This is, again, one of the studies we started doing to look at the degree of repetition you get across blocks. We were setting out all of the key M&E principles across the entire territory, so we had a good understanding of exactly how the utilities and the vertical interfaces worked before we started building buildings. So we were working at lots of different scales, producing 4D models of buildings generally, right down into the detail of exactly how these little bits, how the drainage connection works, and this is how the bathroom goes together. So again, before we started designing buildings, we knew exactly how we were going to do fire stopping between slabs, and we knew how we were going to build the bathrooms, which again blew the client's mind, but it was the only way we could control all these things before we let the architects move on speed. So we likened that to having developed this whole kit of parts. We had everything you need to make a car. What we then needed to do is try and teach the architects and the supply chain how to get that bucket of bits and turn it into one of these. It's actually a different car. It's not I couldn't stop the image of the right car. So we developed a series of tools that have been issued out to the team. So we did a design guide that we take the architects through and tell us exactly what are the rules that you have to stick to on the plots and what are the things you can flex. So we always said we won't have developed every component you need to build every building, we'll have developed 80–90% of them. And we encourage the architects to bend the rules, to break the rules, to say it'd be useful if I had a widget that did this, and we're constantly trying to refine different parts. I think one thing that surprised the client before they met us and they were trying to procure this idea, they thought that the answer would be cookie cutter building. So we would have a basic tower building, basic townhouse block, we would allow the architects to tweak them. We surprised them by saying, no, the answer is to produce a very limited kit of parts. And just in the way, if you give the same bag of Lego to 2 5-year-olds, they'll come up with something completely different. We said the architect will start to develop their own architectural style, but using the same kit of parts, and that will be a much bigger sell in terms of the lifestyle and the appearance of these buildings compared to what you traditionally get in Russia. So again, taking this chassis principle, we set out principles around which bits are completely standard, so things like the cores and the stairs and other bits of the building you don't want to be reinventing endlessly, you want those to be very standard. By the time you get out to the facade, you want it to be very flexible, you want the architects to have the ability to do different things. So we gave them this sliding scale of how fixed your rules are versus how flexible your rules are. And again, it's allowed us to create these individual buildings. We have all of these standard interfaces and details that we can start to engage the supply chain on and get into lots of detail around how quite sophisticated bits of building come together that we can then give the architects to give them this palette of materials and this language of architecture that we start to develop. One critical thing we had to put in place was a modelling strategy. So we have a document, you can see some screen grabs from it, where even if you're a quite basic Revit user, so the client chose Revit as the software of choice. This tells you literally how to assemble one of our models using our components, how to populate rooms with data, how to put all of the bits of kits together. As we developed the kit of parts, we were talking to the cost guys to say what sort of things do we need to be able to extract from this so you can do cost planning. We were talking to the logistics guys to say what sort of things do you need so you can do supply chain engagement, logistics planning, vehicle planning, all of those sorts of things. So as long as the design teams use this guide, they're actually producing vast quantities of information in the same time it would take them to normally produce a set of drawings of the buildings. We produced a fit-out guide so we could be talking to the marketing people, and again getting into lots of detail around the finishes, the materials, the colours, all of these things that make up the lifestyle sell. to make sure that we have this continuity all the way from initial design stages right through to delivery of construction offsite. Results were, this is why we care how much our buildings weigh. This is traditional precast in Russia. This is our building. We weigh about 1/3 the mass of the building. So that's massive reduction in embodied energy, so carbon, the number of vehicle movements on site, the number of logistics, planning interfaces, number of people on site, all of these things. So we're driving down every single component as far as we can in terms of optimising it. We've massively reduced the cost and volume of the rest of it. Cost metrics, for a single building, we would be a reasonable amount, sort of 15-20% cheaper. Across the programme, we're about 25% cheaper than traditional, which is massive for Russia. These are two comparison programmes. One was before we got hold of it was a baseline programme before we started, and this was the programme after we developed the system. So about the same at the time, you can see this building's about twice the size of this one. Well, if you compare two buildings that are like for like, we're about 8 months quicker per building. Across the entire programme, we're saving a year, which as a developer in terms of cash developing is a massive benefit. These are old images, unfortunately. I've got some fantastic new ones, but I'm not allowed to show you one. But this shows you the range, or part of the range of building types that are happening across the plot. We've got about 35 buildings developed now, and they're all quite different. There is a degree of commonality because it's residential, and that drives a particular sort of grid and particular sort of look. But I'm quite pleased actually. We've had no pushback from the architects. No one said that we prevented them from designing a building that they're happy with. But at the same time, we can output massive amounts of information from all these models at a very early stage. And this is one of my favourite shots at the moment. This is all of our structural models that we've developed, lumped into one model and put together. And you can see range of architecture, but you can also see it's made up of that exact same parts that I showed you right at the outset. So that's a bit of a whistle-stop tour. I've noticed I've slightly run over time, but I hope that gives you a sense of what it is we're trying to do and the scale of the project, and actually the fact that it's been quite successful so far. So thanks for listening to my disembodied voice.
Yeah, thank you very much, Jamie. Please a round of applause for Jamie. Okay, we are running over a little bit, but I think having Jamie on the line is a fantastic opportunity for maybe one or two questions. So I'm going to take maybe a couple of questions from the floor, please. Everyone's stunned.
Observation. Isn't it a shame you have to be doing this in St. Petersburg? No, it's good in one respect because you're doing what you should be doing, but we can't do it over here. You have to go to far-flung places to get it done. Shows lack of vision, I think, in the UK, which is terrible. Terrible thing to say, but What do you think, Jamie?
Well, I think you've heard this story from me before. Actually, we got asked pretty much the same question in the UK at the time that the Russians asked us how to do this. The Russians said I need to build 15,000 apartments really quickly and cheaply. What do I do? I won't name and shame them, but a similar developer said I need to do 1,500 in the UK. What's the plan? We showed them both pretty much the same set of ideas. And the Russians said, fantastic, come to Russia and do more of it and do it quicker and really push the boundaries, challenge everything in a place which is known for not being very hard to get innovation across and very hard to challenge the system. At the same time, the UK lot just bottled it and said, no chance, can we just get blokes on site with wheelbarrows and things? So I found it personally very disappointing that actually it was harder to get this idea across the UK than it was in Russia. And a lot of the ideas we're doing on this are things that we talked about on the Athletes Village, but as you know, Richard, my personal frustration on that, a lot of the ideas we suggested, the incumbents just said, no chance, you can't do that, will never work, it's too radical. So yeah, it's been a bit of a nuisance. I had to come to Russia to do this, but at the same time it's been a fantastic opportunity, and the fact that we have a client that is really backing this and is really helping us to drive a degree of change out here which is unprecedented has been a fantastic opportunity. So it's good fun, but we'll end up exporting this back into the UK because once we've done it, people say that's a great idea, we should do that in the UK. Probably should.
We'll take a question.
Jamie, are you producing code information for the buildings as well?
We've been trying to get the client interested in using Kobe as the sort of way of transmitting information. They're not quite there yet. They bought the idea of BIM before they really knew what BIM was. So between us and Sean Farrell from Macy, who's out here as well, we're trying to take them on this journey. We're trying to get them to use it as the interface. One thing we're about to struggle with is that the supply chain, I think, aren't quite ready for this. So we keep saying you've got to start with the end in mind. So we're now saying we'll develop these models to a certain level, but if the supply chain can't pick them up and do anything with them, then that starts to become difficult. And certainly once we get into Kobe, it's not that well understood in the UK yet. Trying it in Russia has been quite difficult. So we're sort of testing it for our own benefits and for our own purposes, but I don't know yet whether it will start to become the common language across the project.
One final question here, Jamie, from myself. It's Stephen from MBS here. Well, in terms of the documentation that's being used on site, do you have it translated to Russian, or do you have it in international English?
No, we do. So a lot of the things we have to do in Russian. So their equivalent of building control, which is way harder than building control, has to be in Russian, and that's been a massive learning curve. The tender documentation, the site documentation things is in dual language because project managers and most of the clients speak English, everyone on site speaks Russian, and we have to know what our drawings say, so we do it in 2 languages. So there's loads of either very fun or very dull things we could talk about. Trying to get Revit to do things in Russian is not straightforward. They're on the data level, but yeah, we are producing things in both. So I can read quite good Russian. I can't speak very good Russian yet.
Fantastic. Okay, we'll take one more round of applause for Jamie. Thank you very much. Okay, we will now be breaking off into our first session of roundtable discussions. These will last for about 45 minutes each. So we'll just compress the time a little bit because I really think it was worth hearing those 2 presentations for their sort of full length. So now if we could please move to the tables allocated for the discussions you've signed up for. I'm going to do a bit of a reminder here. Or I'm going to ask table 1, which is
at the back of the room.
At the back of this room will be Richard Osden, Build Offsite, Future Trends in Offsite Manufacturing.
Table 2.
Table 2, which is in the room to the side, will be Pete Foster, Premier Interlink, BIM for Offsite from a small medium enterprise perspective. Table 3.
In the far room.
In the far room is Mark Taylor, BAM Construct UK, Contractors, Use of BIM on Site. Table 4,
in the far room.
In the far room also will be Rob Francis Skanska. In table 5, which is sort of diagonally across the entrance area, is myself, BIM and level of development. So if we could please make our ways to where you've signed up.
Really well, actually.
Yeah,
you deserve a medal.
Coming from Russia.
We tried 3 different technologies this morning to get to that point.
So you used Skype?
That was GoToMeeting. Yeah, GoToMeeting was Skype to work. And we couldn't use Google Hangouts because USB networks blocked Google+. We'd have to go to Sweden and get their permission in Sweden to work we don't even like this. We've had speakers from Colorado, Texas, Florida. It's social media. It's got people communicating, having conversations online. Exactly what we
see. There's another example. We were talking about communication this morning, and a lot of people are blocking communication. People are just not saying, "I can't show you this," and it really pisses me off because a lot of the youngsters will be so inspired. They can see.
many of those youngsters are coming out of schools, going to universities, intuitive collaborators, intuitive users of technology, committed to open sharing of information, they do it naturally,
Exactly.
and they get that collaborative spirit knocked out of them when they go into
I
industry.
couldn't agree with you. But it needs to be changed.
Yours in the far room.